In this video, we are going to discuss the character and string data types of the .NET framework. The character and string data types represent the text handling capabilities of C# and all of the .NET framework languages. A char, or char, depending on who you ask, is declared like any other value type, except when you assign a value to it, it is typically going to be a literal character, such as the capital A on the screen, delimited by apostrophes, sometimes known as single quotes. The apostrophe is specific to the character data type, and it is used to delimit your character data, much as the quote is used to represent the delimiters of a string. You cannot contain more than one character in a single char value, and the value must fall between the numeric values of 0 and 65535, since a character is 2 bytes in memory. Why it's 2 bytes instead of 1 is to support more languages than just American English. If we were using strictly ASCII, the American symbolic code for information interchange, if we were just using that, then we could get away with 256 characters without any problems. But since Windows and most operating systems today, including the internet itself, they all use Unicode as the basis for their character formats. And by default, that means a minimum of 2 bytes per character to support, as I mentioned, up to 65,000 approximate glyphs. Since characters are value types, if I create another character and I assign to it the value of the first one, it is going to copy the contents out of the stack for the first variable and place it into the contents in the stack for the second one. So these are now 2 completely independent characters in memory, and if I change CH or CH2, it will not affect the other. There are other types of characters which you can place inside of a char variable that can't be represented necessarily by something you type on a keyboard. For those, you could run the char map program by holding down the Windows key and striking R, typing char map, C-H-A-R-M-A-P, hitting enter, and then you'll be greeted by this character map program. In here, you'll see all the standard American English letters like A through Z. Then you have the numbers as well, 0 through 9. And many of the symbols that you see on your keyboard, such as curly braces, parentheses, comma. However, looking towards the bottom of this grid, you start to see characters that are not visible on a keyboard, such as the copyright symbol or the registered symbol, or we have this degree sign, we have a superscript 2, 3, and a 1. Notice they're not always in a logical order. But all of these different values are represented by a special code which you can see at the bottom left of the status bar, which says, in the case of superscript 1, it is U plus 00B9. The U plus simply refers to the fact that it's a Unicode value. The 00B9 is really what we're interested in. That is a hexadecimal value that represents a character in this Unicode list. Let's pick a character that we're familiar with, like A. You'll notice that the Unicode value for A, if I hover over it, it says U plus 0041. It's not 41, it's 41. That's actually the value 65 in decimal. So I can exchange this A with a backslash U 0041. Now that will represent the same A value. I can prove it by doing a console write line. Then I'll say CH plus, and I'll put some spaces, and then CH2. And we'll run, and you'll see A and A. As you probably guessed, if I did 4, 2, I should get an A and a B now. Now, the reason I'm not using any of the other fancy characters, like let's look at copyright, for instance. That would be A9. Let's go back to copyright, A9. If I type in A9 here and I run it, you can see it only shows us a lowercase c. That is a limitation of the console window, not of .NET itself or C#. There is a smaller subset of the font that's used to display characters in the console window. So instead of having all 65,000 possibilities, you can only print most of the ASCII characters plus some of the characters with accent marks. So it's not that it's doing it wrong per se, it is just not capable of displaying certain values. But it is still a copyright symbol. If we put a breakpoint here and run up to that point, if I hover over CH2, you can see that it is 169 is the value given there, but it's the C with the circle around it, indicating copyright. But this \U brings up an interesting topic in itself. Anytime a backslash character is encountered within a character literal, it indicates whatever follows it is something special. Sometimes this is known as an escape sequence. For instance, I cannot put two characters together here in the ch variable because it interprets A as being the character I'm trying to hold inside of this char variable, and the second A is it's unknown what its meaning there is because I've already defined a full character with that first A. So I have to remove that second A to make it legal again. But then you look at this, and there are 6 symbols within the apostrophes. Clearly more than one. Well, that backslash, as I said, indicates that something special is following. So instead of assuming that it can only be one symbol, it bases what can follow on what the next character after the backslash is. In this case, it's a lowercase u, which stands for a Unicode character. And it requires, by definition, 4 hexadecimal digits, 0 through 9 and A through F. Those are the possible combinations. Another common escape sequence, I'll call this character tab, because that's what we're going to embed within this character. This \T represents the tab character. The tab character literally means tab, like on your keyboard. So let me take this console write line and put it here on the next line, and I am going to append these characters together as such, but I can't just do it like this because characters are numeric in nature. Again, they represent an unsigned value between 0 and 65535. If I were to try to print this right now, I'm going to actually get the sum of ch plus tab plus ch2. If I run this, you'll see the value is 243. That is not really what I'm looking for. The reason it worked in the first example is because it was doing an implicit conversion to string based on those spaces that I showed up front. So to get around that problem, I can reintroduce a string to the beginning of the output here. Now everything that's concatenated to this will be converted to a string. And you can see A and then C. And if you count the characters, it goes 1, 2, 3, 4, 5, 6, 7, 8. So by default, tabs will go to the next character alignment every 8 characters. What happens if I actually wanted a backslash in my character? We'll call it BS for backslash. In that case, we have to use an escape sequence where the character following the backslash character is another backslash character. Now this will represent a single backslash. Even though it looks like there's 2, you need this escape sequence to indicate it is just a single backslash. There are other useful escape sequences, such as \r or \n for carriage return or new line, respectively. \apostrophe means literally the apostrophe character, where \quote literally means a quote character. This way, you can have an apostrophe, call it A, inside of your character. Looks a little strange because it looks like apostrophe \, then double apostrophe, but this is how you would embed an apostrophe directly within your character unless you wanted to use one of the \u Unicode values. Characters by themselves are not going to be exceptionally useful in your programming. Most of the time you deal with characters within the context of a string. However, there are some methods of the char type that will allow you to do specific things when dealing with characters. If we had a character called num and I set it equal to the value of the one character, not the value 1 like a number 1 in an int, but the character 1 if you type it on the keyboard. If I want to get the numeric value out of this num character, I can use char dot get numeric value and pass it num. And this is going to return a double. I know it seems kind of strange that it's only going to be a single digit. Why does it have to be a double? It is just the way the method is defined. So we will just go with it. And now when I run this code, I'll put a breakpoint here and start. The value is going to be 1. If the character I supplied is not a numeric value, such as the copyright character, I happen to know that's Alt 0169 on the numeric keypad, and I run this code again, now you'll see val is -1 because it's not a numeric value. So that's a fairly useful method when working with characters. There are other methods like that, such as isDigit, isLetter, isLetter or digit, isLower, isUpper. All of these methods to help you determine what is contained within your character. Usually it's based on a certain range of characters that are defined to have special meaning. So isDigit is going to determine if it's the values between 0 through 9. isLetter determines if it is a letter as you would type on a keyboard. isNumber is similar to isDigit, except it's also going to look at other glyphs such as the 1/2, 1/4, and the superscript 2, for instance. All of those are technically numbers, so isNumber will return true for that, but isDigit, those would have all returned false. You have another isPunctuation method as well to determine if a value is punctuation. And this is a list that you can go through just by typing in char and dot, and you can see all of the different methods that the char data type supports. So if you have to process a string one character at a time and determine if the character falls within a certain class, like a letter or a number, there are methods built into the char data type to help you do that. But as I've mentioned, characters by themselves aren't particularly useful. Typically, we work with them when they are joined together into something called a string. And a string can sometimes be considered a char array. We'll call it text. However, that's not entirely true. A string in .NET is an entity all to itself. It is not a character array. You can convert a string to a character array once it's built. However, the data structure itself moves beyond a simple character array. And there's a reason for this, because strings can not only contain single characters, it can contain modifier characters, which in terms of memory storage will be a character followed by several other characters, and those follow-on characters modify the first one. So it might add an accent mark or change the spacing. And so it's not really just a character array. There are a bunch of other things that are going on behind the scenes that make a string a string. So don't get tempted into using character arrays like strings. Strings in .NET are a formal data type all by themselves, and you can assign to them literal values like this, ABC. You see another literal string at the bottom here which says press enter to quit. I used another one up here when I did the console write line with several spaces to separate CH and CH2. And then in the next console write line I have another string, but this is an empty string. Notice it's just two quotes together. That's a legal string. Sometimes instead of seeing the double quotes like that, you might see string.empty, which will essentially give you the same value. But what can we do with strings? Well, we've seen at the top here, we can pass strings to the console write line method. So strings can be used as the primary means of communication with the console. For instance, we could create a string called name and assign it string.empty as its default value. Then say console.write, enter your name, and then name is equal to console.readline. So we are getting a string out of the console readline method. We can regurgitate that back to the console by concatenating two strings together. By the way, when you see plus between strings, that means concatenation, not add. Even though it is the traditional add operator, this for a string means concatenate, tying the two strings together. Running this, we'll get past the breakpoint. I'll turn that off. Enter your name. I'll type in Bob. Then it says your name is Bob. So you can see we have the ability to concatenate strings as such. What other things can we do with a string? Well, if we wanted to search for a specific character, there are methods inside of the string type that provide such capabilities. So if I'm looking for either a substring or just a single character, I can use one of those methods, such as name.indexOf. And then there are many different things I can provide, either a single character or another string. So if I'm looking for the first n, I could say, what is the index of the first n? And then I could also have said, instead of looking for just n, maybe I want to look for name. And I'd have to put that in quotes. Now, since we don't know what the user typed in, it could have been Bob, it could have been Bill, it could have been Sally, it may not find any of these values, n or name. So when it cannot find a particular value, index of will return a -1. So as long as you're watching for that eventuality, you should get the results you're looking for. Let's go ahead and print this out. Let's do the console write line and then index. Notice here I am using an add or a plus operator between a string and an int. By default, this functionality is going to automatically convert index, which is an int, to a string and concatenate it together. So it'll simply say index colon space and whatever the number is. And I'll repeat that same operation here. So if I run this, if I type in the name Bob, I would expect to get -1 for both of those. However, if I typed in Andy, I should get a 1 for the first value because it's 0 based. 0, 1. 1 is the first location of the lowercase n, but there's still no name within that whole string. It doesn't contain name as such. What happens if I typed in all capital letters? You'll see that it returns -1, and that's because by default the index of value is going to look in a case sensitive manner. So the little n and the big N, they don't match. So we have no match in this result. So they both return -1. What happens if the user entered a bunch of blank spaces at the end of their string? Well, let's do this example where I could say console write line length, and then we'll get the name dot, and then if you want the length of a string, there is a length property. And then I will say name dot trim, which will remove spaces, white space, from the beginning or end of the string. But I can't just run it and do nothing with it. I have to reassign it back into name because it doesn't change the original string. It makes a new one, and that's what we're going to replace the old one with. And that's actually a very important distinction. Strings are immutable. They can't change. So if I were to actually overwrite a variable, such as s, this creates a brand new string in memory, and the old one is thrown away. If I were to concatenate to it, like s equals s plus d, and I'll move this to the top here, if I do something like that, this does not just manipulate the original string s. It creates a brand new string in memory, puts the d at the end, well, after it copies the original string data to the new location, and throws away the old location and points s to the new location. This sounds familiar if you've already looked at working with arrays, because arrays have the same behavior. If you change the length of an array by appending a value to the end, you have to do something very similar, where you must locate a new chunk of memory to store the contents of the new string, and then you throw away the old one. Okay, let's get back to this length discussion, where we say the length is equal to this name.length. Then we trim it, and then let's do the length output one more time. Let's run the code. When it asks for me to enter my name, I will, and I'll put a bunch of spaces at the end. You can say see that the original length is 11, and then when I trim it, it is now 5. So my name is in fact 5 characters long, so it got rid of all of those trailing spaces. If I were to put spaces at the beginning, and say Bob, and spaces at the end, you can see the original length is 14, but the final length is 3 because it extracted and removed all of the spaces prior to and after the Bob characters. Strings share many of the same escape sequences as the char data type. So if I wanted to represent a file with a directory on my file system, I could identify it with string path equals c:\test\temp.text. And as far as you can tell, this is a perfectly valid path name. However, I'm going to show you what happens when I try to print this out. We'll enter my name, it'll just be blank. So we have c:, and then a big space est, big space emp.text. What happened? Remember the escape sequences. \t corresponds to the tab character, which means that's what this is being interpreted as. So it sees the \t and says, oh, you mean to put a tab character there, and replaces \t with a tab. And it does the same again here. which is why I picked these particular names, just so I could emphasize the problem with using backslash characters within your strings, because they do initiate escape sequences. So to fix that, like I showed you above, it would be two backslash characters together. As such, if we run it again, now you'll see it looks correct. However, you may not like doing this all the time, and you may have no need of escape sequences in your strings. If that's the case, then you can prefix your string with the @ symbol. The @ symbol tells the compiler that for the length of this string, none of the backslash characters mean escape sequence. They literally mean backslash characters. So if I print this out again, now you'll literally see double backslashes in there because I turned off the escape sequences. So to fix that, I would get rid of the second backslash in each of those pairs, and now it is correct. But this leads us to another interesting method, ends with or starts with. The ends with method I use a lot when doing file processing. And the reason is I might have a directory or I might have a file name. And one of the easiest ways to check if you have a directory or a file name, or when you're trying to append them together and you don't have any helper classes, you can check to see if the trailing character is a backslash to see, oh, that indicates it's a directory. Doesn't always work that way, but it's one possible approach. So to test to see what that last character is, I can use path.endsWith, and then I can type in a string, and I could also tell it to ignore the case and what current culture information to use. So if I don't want to stick with American English, so that way if I was looking for a T at the end and not a backslash character, I could specify T like this, and at first it's going to indicate false. Say EW for ends with. This is what I mean. I'll copy the console write line and print out EW. And when I run this, you'll see that it does indeed print false. As I mentioned, I can have additional parameters to indicate if I want to use case-sensitive string comparison or not. In Windows, there is no difference in a file name if the character is uppercase or lowercase. So it doesn't make that distinction. C# is a case-sensitive language, but the Windows operating system, for at least the file system, is not. So I could say string comparison dot, and then invariant or ordinal ignore case or current culture ignore case. The current culture ignore case is going to use the current culture settings to determine whether or not two characters are the same based on the current language. Invariant culture is going to use a generic mechanism for determining whether or not two characters are the same, so it's not going to be tied to your specific culture. This is a good one to use if you're going to deploy in possibly in many different locations. Or we could use ordinal ignore case, which uses the order that the characters show up in the character pages to determine whether or not they are in fact the same. Typically, I'm just going to use current culture ignore case. Now when I run this, you can see the answer is true, which means the capital T and the lowercase t are, by this culture, technically the same character. Another technique that could be useful is the ability to convert all of the text in a string to uppercase or to lowercase on demand. This is useful if you're prompting the user to quit, for instance, like press Q to quit, and they type in either a Q lowercase or a Q uppercase. And you want to be able to quit for either one. Well, then what you can do is convert their input to either upper or lowercase and then just always compare against that specific case. So I could take this path, for instance, and say path.toUpper. And again, I can't manipulate the string directly, so the result is going to be stored in itself, essentially. We say path.toUpper, take the results and put it back into the path variable because it is a brand new string. And now when I write out the path, make sure I change this variable, you can see everything went uppercase. You could also do, instead of to upper, there's to lower. And it accomplishes the same thing except the other direction. What happens if we wanted to get the individual components out of this string as separated by the backslash delimiters? For a path or a directory in Windows, that separates individual paths from each other. But what if we wanted to get the C colon by itself, test by itself, and then temp.txt by itself? So we can look at the individual components. I'll create a string array, and I'll call it split, and I'll set it equal to the path string dot split is the command I'm calling, and I'll pass it a backslash character. Remember, it is double backslash for a character to indicate a backslash. I can't use the @ symbol in front of a character delimiter like I could with a string here. That's not legal for a character. So to indicate a backslash, I have to tell it double backslash within the character delimiters. Now, split is an array that the first index will contain C colon, the second test, and the third will be temp.txt. And I can do a for loop equals 0, I is less than split.length plus plus I. And then I could do a console write line split index I. And if I run this, you'll see it broke it up, C colon, test, and temp.txt. If I wanted to put that string back together, there is a string.join method. And notice here, split you call on the string you wish to split, but to join them back together, you call join off of the string type itself. And then you tell it what to join and using what delimiter. So the separator I'll use, and it's looking for a string. So I'll tell it backslash. Remember, I need the double, or I can use the @ symbol to specify a single. And then I can tell it split is the data I wish to join back together. And I'll call this new path. And then I'll write new path to the console. And I hit run. You can see it is now back together again. What about testing two strings? Well, this is a perfect segue for that because I have two strings which fundamentally contain the same data. We have one that contains path, which is the C colon backslash test backslash temp.txt, and then we have new path, which contains the same information. They're both uppercase at this point, so technically they're the same. So I could say bool same is equal to, and then there are several ways we can do comparisons. We could say path dot compare to new path equals 0. What did I just do here? Well, there is a compare to method that's part of string. So I call compare to on my path string. It doesn't matter which one I use here. And I pass to it new path. So it's going to compare the two, and if the result of that is 0, that means they're equal. So I take this expression and I assign whether or not that's true or false into the same variable. So I'll print out same, and you'll see, yes, it is true. What about the standard equals operator? Could I change this code to do this. And you may be more comfortable seeing this written as such. Put it in parentheses, so you're saying, okay, that's being done first before the assignment. It might make it easier for you to read. It's the same exact operations being done, but it might be easier to read. And the answer is yes. This is actually an interesting result because strings are technically reference types, which means reference compares on two distinct variables will typically return false. However, because the string changed the meaning of the equals operator, this double equal symbol, it actually does a comparison of the contents and returns true or false based on that. Let's use several of these methods together to produce a single result. Let's say we were interested in extracting temp.text without using split. What we could do is, if we scroll back to where we're getting the index of values, I'm just going to copy this code because that's what I'm going to start with. And I'll say index is equal to path.index of the backslash character. But instead of the first index, I want the last index. So it's going to look for this particular character. And then I can create a new string, and I'll just call this sub, and I'll set that equal to path.substring. I tell it where to start, which is going to be index plus 1. I don't want the actual backslash, I want the character after it. And that is going to give me all of the data in the string after that backslash and put it in a new string called sub. Now you've got to be careful with substring because there's another version of that call or another overload where you also pass how many characters you wish to extract, and if you ask for too many, you'll get an exception. So unless you need to limit how many you're reading, if you just want from the current position all the way to the end, it's always safest just to use this particular overload and just say, starting here, give me the rest. But if I knew I needed exactly 8 characters, then I could provide comma 8. But let's just do this one first, and then I'll demonstrate the exception. So you can see temp.txt was extracted and placed into the sub variable. But let's say I wanted to do it with an explicit length. I'll run it again. It should work. Again, temp.text. And if I told it instead of 8, I told it 4, now I should just get the temp. As you can see here, temp. It's because I only requested 4 characters instead of all 8. What happens if I ask for 9? And I hit run. Now we're going to get an exception which says argument out of range, which is something you really always want to avoid. The final thing I'd like to show you is the test to see if a string is either null or contains no characters, or all white space. Usually this is going to be used in conjunction with an if statement. So I'll start with if, and then it's going to be string, and then I have is null or empty, or is null or white space. Use is null or empty to test if a string is completely null or empty. To do this, I'm actually going to pick a different string. I'll call it test. And then we'll just leave it at its initial value of null. So then I can say it is null. When I run the code, oh, I forgot to fix this 9, didn't I? Let's put that back to an 8. Let it continue, and then you'll see it is null. If, however, I wanted to test to see if it was a string that contained only white space characters, let's change this from here to here. Then I'll run the code. As you can see, we didn't get the output this time because it is neither null or empty. However, if I change this null or empty to is null or white space, now when I run the code, it will detect that as white space and print it is null. Probably should change this to null or white space. This is a very useful test, especially when you're reading data from the console using readline, because you never have any idea what the user is going to enter. So these tests will allow you, at a minimum, to make sure that they enter something. There are many other things you can do with strings, such as manipulation of the strings by changing its contents. However, I'm going to lean you away from using those techniques because strings are immutable like arrays. In other words, you're not really supposed to change their size after you've created them. So if you get into the habit of using some of those methods for manipulation, like replace or remove, you're going to get into trouble with speed because you're going to be doing a lot of memory reallocations. This is especially true when you're doing repeated concatenations. It's okay to do concatenations when you are assembling an output string such as this because it is not actually changing existing strings. It is creating a new string based on the length, literal, and the integer that's stored in name.length. So this is not manipulating existing strings, it's creating a new one on the fly. That's okay. What I'm talking about is when you have a string such as test, if you wanted to augment it by saying test equals test plus a. This is what I want you to avoid using. Instead, I'll point you to another data type called string builder, which is for another conversation.